So we don't have to start over again. We've now drawn a conclusion. Now in actuality, in most testing that goes on, it is an iterative process. When I learn that P1 is not equal to P2, that tells me that these two are different. There's usually some follow-on work that we'll end up doing. But as far as this hypothesis test, we are finished. It looks bad. However, almost everything up here is a simple variation from what we saw for a single proportion. The only thing that is a little bit more complex is when we get into this here and we bring in this new p hat there. Other than that, I think if I'd have asked you guys, in some cases we did come up with the obvious answers for each of these. And so what we've got is something that's very similar to what we did for the single proportion. Okay? So let's try. .41, 10.42, and 12.68. Work on those problems. Ask questions as you need to. Before we get done with class, we'll talk about them. We'll go through solutions for them if necessary. What I found in the 1 o'clock section is that by the end of the class, people felt pretty comfortable with doing the confidence intervals, and so there wasn't too much of a problem there. And we talked through the case for the hypothesis test. The other thing I'll do with this, I'll also put the solutions to these problems out on the blackboard and attach them to the homework assignment so you can get at them as well there. In fact, I'll probably do that while you guys are working here. Okay, on the stuff on Chapter 10, do people feel reasonably comfortable about the stuff in Chapter 10? In most cases? Okay. Let's take a quick step through the stuff in Chapter 12. So take a look at Chapter 12, number 68. The way they've got this set up, we should have P1 minus P2 is equal to 0. So that's going to be the same for every one of these. We've got P1 minus P2, and what they've got written down here is greater than 0. And one of the key things here is that whether it is greater than 0 or less than 0 depends on how you define P1 and P2. Now here, in order to get a greater than condition, they've defined P1 to be the proportion of men who would stick with a losing investment. P2 is the proportion of women who would stick with a losing investment. So if I define it in that order, then I have a greater than sign here. If I defined it such that P1 was the women who would stick with a losing investment, then I would have essentially a less than sign because I've inverted the order of this. So you have to be careful how you do it. Make sure when you write your hypotheses for these cases that you write down which is 1 and which is 2. That way I know which way it is. Now, if it's a not-equals condition, here, it doesn't matter, does it? For a not-equals condition, it doesn't matter which one is P1 and which one is P2. But it's a good idea to get in the habit of just writing them down. Okay? Checking our conditions. Our conditions, they said, are met, so we have at least 10. And actually, the quick way to check these conditions is to make sure that there's at least 10 in each category of each subgroup. And so the conditions are met. Our sample statistic, did anybody calculate the value for Z? What'd you get? .03. The value of Z? 12.68.
Yeah.
You should have P1 minus P2. This should be, you should come up with 0.12 here.
Yep.
Over the P hat should be 0.1.
You got 0.41 there.
Yeah, 0.41. N1 is 500, N2 is 500. And according to this, when I punch all that into the calculator, the 0.0311 is this denominator.
Oh, okay.
So you've got 0.12 divided by 0.0311. And then you come out with actually you come out with 3.86. This is why what I want you to do is I want you to write the numbers into the formula for me. So if you got all the numbers in the right place in the formula, I can give you full credit for it, even if it doesn't come out with the right value. Okay? So the number is 3.86. Z is 3.86. It's a greater than condition. What would your conclusion be in this case?
What p-value did you get?
Well, even before you take a look at the p-value, if it's a greater than condition, we want a right tail. That means we're going to take 1 minus whatever we would look up in table 8.1. If we look up the 3.86 that we get for Z in table 8.1, that's off the end of the table, right? So we're going to get something like 0.999 something. So 1 minus that is going to be something like 0.000 whatever. We've got a very small value that says that the likelihood of seeing this particular observation, if in fact this were true, is very small. So we're going to reject the null hypothesis. So we've got a value that's much less than 0.05. So reject the null hypothesis. That means that in fact the proportion of men who would stick with a losing investment is greater than the proportion of women who would stick with a losing investment. Okay. Questions? Solutions are out on Blackboard. If you go back to the assignment, the solutions are attached to that assignment. We've got homework due on Monday. We'll see you then.
The quizzes we can still do up until Monday, right?
Yep. Actually, 8 o'clock Monday morning is when it shuts down.
Okay.
So do it Sunday.
Okay, yeah. Okay. We're talking about the quiz?
Yep.
Yeah, until Monday, right?
Actually, it ends Monday morning at 8 o'clock, so do it Sunday.
All right.